Well, correct.
Yes.
Okay. So I'll start it again. I'm Prayag. I have more than 16 years of experience, okay, in the IT field, and from last 6 to 7 years, I'm totally into DevOps and currently also working on ML ops, AI ops. So whatever ops part, I'm almost comfortable with it and kind of an expert. Okay, but DevOps is my primary skill. Okay, and currently also I'm working on a large DevOps environment. Okay, and I started my career as a Linux admin, and I know it how painful it is to work in DevOps because we have to work closely with the developers, and you all know developers are geeks. Okay, they are really geeks. Okay, and they are always demanding. Okay, they need everything latest. Okay, they always like to work on latest technologies and all. So that's also one of the pain point we need to face when we want to transition or start with the DevOps role. Okay, so you all must have heard that DevOps is generally for professionals. Okay, and freshers are not recommended to join the DevOps courses and all. But I don't agree completely with them. I have made the DevOps very easy for everyone. Okay, so we won't be able to cover everything in 1 hour or 1.5 an hour. Okay, but I'll give you a foundation of DevOps, what it is and why it is so useful and why everyone is talking about it. Okay, so agenda for today is quite short, but to the point. We'll start with the application. Okay, so DevOps and whole IT world, it revolves around application only. Okay, so we need to keep the application always available, highly available. It should be scalable. Okay, so what's mean by highly available? What's mean by scalable? And why application uh, uptime is very important. That's what the DevOps engineer or senior DevOps engineer or a DevOps architect needs to understand and learn. Okay, so whatever paychecks we are getting nowadays in IT, it's all because of application. Okay, somebody launched Facebook. Okay, Zuckerberg is earning a lot. Okay, WhatsApp. Okay, these are all applications. Okay, we like the application and we like its UI, we like its functionality. So you all know how important the application is. So in DevOps, what we need to do is, as I said earlier, we need to keep it always highly available, highly scalable, okay? And the infrastructure which is required, it should be robust. Okay. So as a DevOps engineer, what we need to do is one of the main area where we need to work is create an environment or an infrastructure which is useful for hosting that application. Okay. And till now in college days or in the early days of our career, how we create the infrastructure manually, right? We'll go to AWS console or Azure console or Google console and we'll create a VM. So that we do manually. For learning purpose, it is good. But in production environment, that needs to be done automatically and with some code. So there comes infrastructure as a code. Okay, so I'm explaining everything. I'm just giving a short overview. Okay, and when the infrastructure is ready, okay, and that infrastructure too should be highly available. Okay, that means if one of the VM or one of the server goes down, the other server or other VM should start serving the traffic of our application. Okay, so creating highly available infrastructure using code is called as infrastructure as a code. Okay, now on the on the infrastructure which we have created, which is highly available and also scalable. Scalable means if there is a high demand, okay, sometimes in big billion days sales, what happens is users uh, send a lot of traffic to the website. Okay, in that case, based on the number of requests or based on the CPU or memory consumption, automatically the server should be added. That's called as scaling. And when the load goes down, okay, the server should be removed or deleted. That's called as scale down. So creating an infrastructure highly available and scalable, and after that deploying an application on that infrastructure is one of the main role of a DevOps engineer. Okay. Now, why there is need for a DevOps? Okay, which problem it solves? Okay, how it fits into software development lifecycle. Okay, what is monolithic? What is microservices? You must have heard. Whenever we heard a word about DevOps, you always hear microservices. Okay, so we also need to learn what is microservices. So we'll go in this sequence. What is an application? Okay, then there is a problem that it works on my machine, why it doesn't work on your system. This always happens, whether it's in the college days or whether it's in production environment in companies. If we always say it is working on my system, check your system, there must be some issue on your system. Okay, so this is one of the main problem the DevOps solves, and where the DevOps fits into SDLC, how it leverages or helps us in achieving a nice software development lifecycle. That's all we'll be learning. And of course, DevOps. So in this section, let's learn about what is application, how is an application made, and what are the application components. Okay. So this plays a main role when we'll be designing CI/CD pipelines. Okay. So what is CI/CD? That also I'll be covering. But let's start with application. So I'm giving a presentation on PowerPoint. Okay, so that's all. That's an application. So most of you know here, if you're from an IT background, that what is an application. Firefox is an application. PPT is an application. Okay, so generally it is a computer program. Okay, designed for a particular task or set of tasks. Okay, so developers generally create the application. Okay, and where does the DevOps engineers fit in? Okay, DevOps engineers need to make it reliable, secure, and it has to be automatically deployed. Okay, next is how is an application made? Okay, so most of you already know, okay, but
Your
this
slides aren't moving, sir. Is it?
I have moved. I'm moving it. Anybody else is facing the same issue? How is an application
Yes.
made? Can you see that?
No, it's stuck on the same slide.
It is stuck on the same slide. So yeah, now it is okay. Okay.
Let's start slideshow. Okay, and let me move. Is it moving now?
Yeah, now it is on application. Okay.
Yeah. How is an application made? Can you see the screen now?
Yeah, you can start from current slide, that slideshow thing, so that everyone can view it uh, on full screen, because some of the people have joined from mobile.
But still again show if it is not visible. Okay, can you all see how is an application made?
No, it's not
Ye-
visible.
I don't know
It
what's,
it went back to the first slide.
Yes, yes.
but it works always. Is it
Actually,
Google,
you will
Google
have to.
issue?
I think you will have to share your entire screen.
Yeah, I'm sharing my okay entire screen. Got it.
Yeah, yeah. Yeah,
Yeah, is it okay now?
yeah.
Yeah. So we know what is an application. Okay, Firefox browser, Chrome browser, PowerPoints. Okay, WhatsApp. All these are applications. Okay, developers code for it. Okay, uh, and DevOps engineer, what they need to do is they need to properly host it on the servers. That should be reliable, secure, and it has to be done automatically. Okay. So most of you already know how the application is made. Okay, but this plays an important role when we learn about uh, building building the application. One of the main role of a DevOps engineer is also to help in build and releasing the application. Okay. So what happens is, suppose you are on C language, then you'll be coding in C language. Okay, the code is in main.c. Okay, if it's Python, it will be app.py. Okay, so whatever source code you have written, okay, that source code generally depends on some libraries and dependencies. Okay, so extra code will need, okay, because the code itself is not sufficient, so it may need some extra libraries and dependencies. Then it's compiled and object code is created. Okay, and if it is not interpreter, okay, like Python and all, then it's linked. Okay, and then it is executed and we get a running program. Okay, so in this whole cycle, when the application is made, you can see there are some libraries and dependencies. This plays very important role, okay, in creating the application, and these are mostly responsible for one important problem. Okay, and that is it works on my system, why it is not working on your system. I'll just give an overview of that problem. Okay, so what are the application components? Source code, okay, extra libraries we need, some dependencies we need. Okay, some examples I have given here. So we then compile it, and executable is created, and we have a running application program. Okay, so it can be something running on a browser or some script as well. Now I'll give one example. So developer one, or let's say developer application developer created an application. Okay, and he gave it to one other person, or a tester to test it, or an operations guy to deploy it. Or let's say that you created one application and you have shared it with your one of your friend. Okay, and what you say is it is working fine, just test it on your and tell me how the look and feel is and how is the working and all. And he says no, it crashed, it's not working on it, you must have done some, you have not done coding properly, देखो coding आता ही नहीं है. ठीक है, this always happens, right? Or tester and developers always fight. Okay. So what is the solution to that? Okay, that is, the solution would be containerization, and how, that I'll explain, and which problems containerization solves, that will cover in the next section. Okay. So suppose you created an application and it's working fine. Suppose it's just a front-end application created in HTML with some HTML and CSS code. Okay. So it's working fine on your system. Okay. You gave it to your friend, or a developer A gave it to a developer B. Then what he will say is it's not working. Okay. It is a developer A. This is the developer A who is saying it's working on my system. Developer B is saying that no, it's not working. It is crashing. So then what the developer did is he went to developer B or your friend's system, and the suppose the application was created with some dependencies, or it is made to run only on Linux OS. Okay, but it's not compatible with Windows, and some libraries were missing on developer B's system. Okay, so this is the problem always happens in the development world, that sometimes the platform is not right, or sometimes the version mismatch is there, sometimes the dependencies are missing. Okay, the code is correct, but whatever dependencies and the third party applications which are needed, they are not proper, and due to that, okay, the application doesn't work, and there is always a problem that it works on my system but it's not working on your system. So what are the reasons? Different operating system, missing dependencies, there can be incorrect version of the software, and some settings or environmental variables are not set properly. Okay, so but what is the solution to it? So let's see the scenario again. So developer, he said that I've written a code, it's perfectly working on my system. He gave it to a tester or an operations guy, and he got a 404 error. He said that it is not working on my system. Okay, then developer makes some changes. He said no, it's working fine. It's quite weird why it's not working you, and this cycle repeats. Okay, now the solution for this is Docker. Okay. So what is Docker? That I'll explain. But in short, we should say containerization is the solution. We know that Xerox is a company, but we always say we do not. We should say we need a true copy. But what we say is we need Xerox. Okay. Similarly, Docker is one of the company name who provides containers or container engines, helps us in creating container engines. But containers and Docker, they are uh, used interchangeably. Okay. So solution to this is containerization. Okay. So here the Docker is saying, I think you both don't know about me. That's why you are facing this issue. I make sure the containerization makes sure that apps will work same everywhere, whether it's your system or anyone's system, whether it's in development or in production, and how. Let's see that. Yeah. So you must have seen large containers, okay, mostly maybe on uh, shipyards and all, but maybe in movies or live as well, that there are large containers. Okay, so if you see, this is one of the large container, this one, okay, and there are some wooden blocks in it. Now there are suppose 100 wooden blocks in it, okay, and if we keep it in one of the containers, and if we pack it properly and move it from one place to another, they will remain intact. They will always be 100 and they won't get shuffled between other containers which are blue or red, blue or yellow color. They will always be as it is in a red container. So what we can do is we will just move this container from one place to another, and everything inside the container will be as it is. The same terminology we can use in containerization as well. So here what used to happen is developer A had written a code with some dependencies, with some operating system, okay, and some versions which were mismatched. Okay, so what the container does is, okay, it will pack the code, okay, it will do the packaging of the source code, dependencies, and whatever third party and whatever environmental variables required in a complete package, okay, and an image is created. Okay, so we won't go deep into how it is done, but an image is created, which is nothing but like a this container. So what this container has, it has code, third party libraries and all, okay, and then this Docker acts as a ship, okay, which will take the container from one place to another. So if the container is placed on a Docker, it is always safe. Okay, that's what the terminology is. So what we do in containerization is we have to install Docker on every system. So solution is every system should have a Docker. Okay, an image will be created which will have everything as it is. So just copy that image from one place to another and run it. So there won't be any problem for dependencies and third party libraries and all. Okay. So this is how the containerization solves the problem. Okay. Now you all must have heard about containerization, and then comes the containerization orchestration. So Docker or containerization will solve the problem of it works on my system. Now onwards, it will work everywhere. Okay. But where does the Kubernetes comes in? Okay. So the orchestration, what does the orchestration means is placing the right container on the right ship. Okay. If one of the ship is full, okay, then we cannot place one more container on it. Okay. So you can consider this Kubernetes as a crane, and somebody will be managing Kubernetes. In that case, we can say a master node is managing other worker nodes. So there can be multiple ships. Okay, one of the ship may be having some uh, space, others may not be having some space. Okay, so the Kubernetes will make sure that the containers which we created earlier, these containers are placed properly on the ships, that is on a nodes. Nodes are nothing but where our
सर हिंदी
containers
में
will be
बताइए.
running. क्या बोले?
हिंदी मध्ये बताइए.
Okay. So everything cannot be done in Hindi, but I'll try to uh, interrelate.
Okay, sir. Okay.
So Kubernetes क्या करेगा? जो कंटेनर है, it will properly place on all the other ships. Okay, whether it will check कि उस पे जगह है या नहीं है, and then it will properly place the containers. So Kubernetes किस लिए यूज होता है? ऑटो स्केलिंग के लिए, हाई अवेलेबिलिटी के लिए. Okay, in short, the orchestration part is done by Kubernetes. तो कंटेनराइजेशन सॉल्व करेगा एक प्रॉब्लम, इट वर्क्स ऑन माय सिस्टम. कुबरनेटिस कौन सा प्रॉब्लम सॉल्व करेगा? सिर्फ कंटेनराइजेशन इज नॉट सफिशिएंट. ओके, टू स्केलिंग एंड हाई अवेलेबिलिटी कंटेनराइजेशन से सॉल्व नहीं होता, तो उसका ऑर्केस्ट्रेशन करना पड़ेगा, एंड उसमें हेल्प करता है कुबरनेटिस. कुबरनेटिस क्या करेगा? अगर किसी सर्वर पे पॉड्स sorry, container, if container dies, then it will make sure that the container, if it is in replication mode, it gets created again properly. So auto healing, high availability, scaling, and all this all is done by Kubernetes. Okay, so which problem containerization solves? Okay, it works on my machine. This is one of the problem. How it is solved? It will package the application code dependencies, and it makes sure that हर जगह पे the application runs identically. Okay, so if you compare the containers with the VM, container starts in seconds. Okay, how and all, for that we'll have to learn about kernel and all. Okay, how kernel is created, how VM and how containers differ. Okay, there are so many things. So slow deployments का solution है कंटेनर्स क्विकली स्टार्ट होते हैं, VMs को टाइम लगता है. जब कॉम्प्लेक्स सेटअप एंड एनवायरनमेंट्स होते हैं, इन केस we'll have to create an image, right? So in that case, Docker file is useful. So there are some various problems which containerization solves. One of them is it works on my system. Okay? So how it fits into DevOps, that also we'll see soon. So why containers and Kubernetes? Okay, it is widely used by many companies, and they are finding it very useful. And now it is passed on to us, and everyone is going for containerization and Kubernetes. Google is using it, Netflix is using it. Okay, Spotify, Booking.com, Red Hat. Okay, everyone is using it, and if the giant companies use it, there must be something. Okay, that's why we also try to make full use of it. Okay, so this is the same thing. What is Kubernetes? If you see how the Kubernetes logo comes, is it's similar to a man, okay, who is managing this large ship. Okay, so Kubernetes का काम क्या है? Containers को properly manage करना, उसको सही जगह पे place करना. So that's what explained here. Is managing the ship properly to manage the containers. Now let's learn about software development life cycle. Okay, monolithic क्या होता है, microservices क्या होता है, that we need to learn. So here we'll cover everything, some methodologies and all. Okay, so remember why I'm explaining all this is, first we need to learn what are the problems DevOps is solving, what are the problems containerization is solving, where does the containerization fits in software development. Okay, how earlier people used to create applications in a slow mode. Okay, how it is created now quickly. That all will be learning. Okay. So just a short, most of you know that how is software created. Okay, earlier we saw a technical method, so coding and all and all. Okay, but here someone comes up with an idea, or they do some requirement gathering. Okay, then they check whether it is proper or not, then designing is made. Okay, then coding is done, it is tested, and then it is deployed. So most of the people follow this method for software development. So most of them know that I came up with the idea. Okay, so इसके लिए क्या क्या requirement लगेगा, they do the analysis and all. Okay, फिर एक rough design create होगा, coding होगी, testing होगा, and then it will be deployed at the end. Okay, so ये है software development life cycle. Most of you know if you are from IT background. So I'm first explaining the different terminologies, and then I'll combine it together. So first concept was SDLC. This is how software development lifecycle works. Okay. Now, most of you must not be aware about it, and most of us have done in college level or as a fresher monolithic kind of an application creation. So what does that mean? Okay, so here let's go to this slide. This is pretty useful. So suppose you created an application which has a user interface, some business logic, okay, depending on business, whether it is for financial or whether it's for entertainment purpose or whatever. And then for we have a database and all, data access layer and all. So in monolithic, what happens is all are combined in a single code base. So what does that single code base means? When we do the coding and when we do build, okay, so build process means compiling it, creating an executable and all. So though the code becomes monolithic, means it's a single code base, and when we try to build it, okay, then it is done at the same time for everything. But in microservices, what happens is we'll separate the logic for user interface, business logic is separated, database logic is separated, data access logic is separated. Okay, that's what we do in microservices. So at at this moment, just understand that monolithic में क्या होता है कि everything build, compile and all, and creating executable is done at the same time. Whereas in microservices, it is divided into subparts, okay, and we do not do at the same time. Everything works separately. Okay? So it will be more clear in the next example. So suppose there is a development team, team A, team 1, team 2 and team 3. All three are working on a single code base. So जब ये deploy होता है तो क्या होता है, एक simple pipeline. Pipeline means deployment process, means we have to deploy the code in the on the server. तो उसमें क्या होता है, single code base directly production में deploy हो जाएगा. So इसके कुछ drawbacks है that we will see next. So microservices में क्या होगा, product team will be different, so there won't be a single code base. So the same code will be divided into three different parts. One will be product, another will be basket, and another third one will be the order. So they will not interfere with each other, and the deployment will be done separately. So suppose here in this deployment in monolithic, the basket code फट गया, इट्स नॉट वर्किंग प्रॉपर्ली, तो क्या होगा, पूरा डिप्लॉयमेंट फेल होगा. लेकिन अगर माइक्रो सर्विसेज में ये बास्केट कोड फट गया तो भी प्रोडक्ट कोड इज रेडी, ऑर्डर कोड इज रेडी, यू हैव टू concentrate on only on the basket code and deploy only that. In this case the whole deployment has to be done again. Okay? So इसमें क्या होता है, डिले होता है. So that's why everyone is nowadays moving to microservices. Okay? So what happens in
प्रयाग सर,
yes,
बिफोर मूविंग टू नेक्स्ट टॉपिक, किसी को यहाँ तक कोई डाउट है? कोई अगर डाउट है तो पूछ लीजिए.
yes, you can ask me any question anytime.
किसी को अगर कोई डाउट है मोनोलिथिक माइक्रो सर्विसेज का, इसके पहले जो टॉपिक बताया या डेवऑप्स का बेसिक ना समझाओ तो आप पूछ लीजिए. हम फिर, नहीं तो प्रयाग सर आगे बढ़े.
Okay, maybe they will have a question when everything is clubbed together. Now I'm explaining different things. Okay? So first problem तो हमने देख लिया कि it works on my system, it doesn't work on other system. Now we are seeing the next problem, that in monolithic we have a single code base. तो इसमें क्या होता है, delay होता है. In microservices में independent services होती है तो उसमें delay नहीं होगा. How that also I'll explain, but it generally happens. I explained it here now कि यहाँ कुछ फट गया So everything is on stake or okay, on hold. But here, if some only one component fails, still two components are in build. Okay, we don't have to stop for the process, SDLC process. So monolithic में क्या होगा, सिंगल यूनिफाइड कोड बेस होता है, इसमें मल्टीपल स्मॉल पार्ट्स में रहेगा. ओके, डिप्लॉयमेंट करते टाइम विल बी डिप्लॉइंग एंटायर ऐप एट वंस. ओके, हियर इंडिपेंडेंटली विल सर्विसेज डिप्लॉय करेंगे एंड देन दे आर interlinked or you can say APIs are called and all. Okay, so जब हमको स्केल करना है ना, बिग बिलियन डेज सेल आ गया है और अभी एकदम से ट्रैफिक बढ़ गया है, तो हम क्या करेंगे, पूरा एप्लीकेशन स्केल अप करने जाएंगे और उसमें टाइम ज्यादा जाता है. whereas if the microservices are small, scaling specific services becomes very fast. Okay, अगर किसी वजह से there is a bug in monolithic application which is a single code base, remember this is a single code base, तो इसमें क्या होगा, entire application affected होगा. but here other applications will, other small services will be still running, only we have to concentrate on the other service. Okay, that won't fail the complete application. So tech stack क्या होता है, generally usually one per application. Okay, here we can even use different stacks. Okay, front end के लिए दूसरा, back end के लिए दूसरा, even front end के लिए two different front ends we can use. Okay, and monolithic is slow. You must have heard, you seen why it is slow, because if there is a bug, everything is halted. Here it's faster. Okay, and it is done in iterations and all. So this is the difference between monolithic and microservices, and which we learned about containerization, right? So Docker and Kubernetes, they help us a lot in creating such microservices. Okay? So we must have linked together what is containerization and microservices. So let's see one example, live example. So we created, suppose we are creating एक shopcart नाम का एक application हम लोग बना रहे हैं, with it is monolithic. उसमें क्या रहेगा, सिंगल कोड बेस में लॉजिक है लॉगिन और प्रोफाइल क्रिएशन का, उस पे एलिस वर्क कर रही है. प्रोडक्ट कैटलॉग है, उस पे बॉब वर्क कर रहा है. पेमेंट के ऊपर चार्ली वर्क कर रहा है. टेस्टिंग इज डन बाय डायना एंड डिप्लॉयमेंट इज डन बाय ईव. तो ये सारे लोग क्या कर रहे हैं, एक ही कोड बेस पे वर्क कर रहे हैं. So one monolithic app means one build, one test cycle and one deployment. If any part fails, the whole app fails. इसमें से एक प्रोडक्ट में कुछ बग आ गया तो पूरा एप्लीकेशन हमको चेक करना पड़ता है by building, testing and deploying. We cannot check only login वाला जिसमें इशू आया था. Okay, but in case this shopcart app अगर microservices में बनता है, okay, तो कैसा होगा वो भी हम लोग देखते हैं. सो जनरली मोनोलिथिक एप्लीकेशन में, स्लाइड ऊपर नीचे हो गई है. सो जनरली मोनोलिथिक एप्लीकेशन में क्या होता है, मंडे टू फ्राइडे ओके डेवलपर राइट करेगा कोड. ओके, मंडे टू थर्सडे एंड फ्राइडे को वो कोड रिलीज होगा, सब कोड मर्ज होंगे, एक ही सिंगल कोड बेस रहेगा. ओके, वो टेस्ट होगा, टेस्ट में बग निकल गया, तो अभी बग निकल गया तो क्या होगा, वो फीडबैक जाएगा कि एवरी कोडर के पास, सब लोग उनका कोड चेक करेंगे और वापस से ये साइकिल रिपीट होगी और इसमें टाइम बहुत वेस्ट होगा क्योंकि पूरा कोड बेस चेक करना पड़ेगा. सो दैट्स व्हाट हैपेंस इन अ ट्रेडिशनल मोनोलिथिक सेटअप. सो माइक्रो सर्विसेज में क्या होगा, जो ये सिंगल कोड बेस था मोनोलिथिक का, उस पे क्या होगा, डिफरेंट पीपल विल बी वर्किंग डिफरेंटली. एलिस विल वर्क ऑन यूजर सर्विस, बॉब विल वर्क ऑन प्रोडक्ट सर्विस, ओके, एंड चार्ली विल वर्क ऑन पेमेंट सर्विस. सब लोग क्या करेंगे, अपना अपना बिल्ड टेस्ट और डिप्लॉय करेंगे, बिल्ड टेस्ट एंड डिप्लॉय करेंगे. ओके, एंड उससे क्या होगा, ईच वन हैज इट्स ओन गिट रिपोजिटरी, CI/CD पाइपलाइन, टेस्ट केसेस, बिल्ड एंड डिप्लॉय प्रोसेस. सो ये सब कुछ हमने अभी तक कवर नहीं किया, लेकिन क्या होगा कि जो भी है इंडिपेंडेंटली हो रहा है. अगर यूजर सर्विसेज में एलिस को कुछ प्रॉब्लम आया तो उसके वजह से प्रोडक्ट सर्विस एंड पेमेंट सर्विस का डिले नहीं होगा. ओके, द सेम हैपेंस इन मोनोलिथिक, उन पे डिले आता है. सो लेट्स सी वन सिनेरियो. एलिस ने कोड पुश कर दिया, ओके, और वो कोड सक्सेसफुल रन हुआ एंड यूजर सर्विस बिल्ड हो गई. ठीक है, in terms of microservices, बॉब ने कुछ कोड को पुश किया, okay, और वो ब्रेक हो गया किसी वजह से, देयर इज अ बग, तो सिर्फ प्रोडक्ट सर्विस फेल हुई, यूजर सर्विस स्टिल रनिंग। अगर ये मोनोलिथिक रहता तो पूरा सर्विस, पूरा एप्लीकेशन बैठ जाता, ठीक है। व्हेन चार्ली डिप्लॉयज, ओके, ओनली पेमेंट डिप्लॉयज में सम अपडेट किया उसने, तो पेमेंट सर्विस अपडेट हो गई। सो बॉब के वजह से एलिस और चार्ली को कोई प्रॉब्लम नहीं आया, एवरीवन इज इंडिपेंडेंटली वर्किंग without stepping on each other's toes. Okay, so this problem microservices solves. Okay, so what are microservices? Different components of an application, shopping cart differently, payment logic different, database is different. Okay, so ये है microservices, and again I'll say that microservices हम किससे बनाते हैं, docker के help से, and उसको scale करना है तो Kubernetes help करेगा, highly available रखना है तो Kubernetes help करेगा। so द सेम थिंग मोनोलिथिक में क्या होगा, एलिस ने कमिट किया, बॉब ने कमिट किया, चार्ली ने कमिट किया, पूरा बिल्ड होगा, पूरा टेस्ट होगा, बग फाइंड हो गया, सबके लिए डिले आ गया। तो दैट्स व्हाई मोनोलिथिक डोंट प्रेफर, पहले ऐसा यूज करते थे, अभी नाउ एवरीवन इज मूविंग टू माइक्रो सर्विसेज। सो माइक्रो सर्विसेज में this is what happens, okay, the same thing we have seen, that if Bob का कुछ fail हुआ तो other builds and deploy are not failing. So same thing again, we'll have to learn two important concepts, what is waterfall, then agile methodology, and DevOps. Three terms I'll explain quickly. Okay, I won't go much technical into it. Okay. So if you see in monolithic क्या होता है, this is waterfall method is generally a monolithic. Suppose SDLC में क्या होता है, हम रिक्वायरमेंट गैदर करते हैं, फिर डिजाइनिंग, डेवलपमेंट, टेस्टिंग, डिप्लॉयमेंट एंड देन मेंटेनेंस, ओके। और इसमें क्या होता है, ये पूरा प्रोसेस, अभी रिक्वायरमेंट एनालिसिस कर लिया, ठीक है, फिर हाई लेवल डिजाइन, फिर लो लेवल डिजाइन, फिर कोडिंग, ओके। अभी कोडिंग होने के पहले लो लेवल डिजाइन रेडी होना चाहिए, नहीं तो कोडिंग नहीं होगी, है ना। देयर इज अ डिपेंडेंसी, वाटरफॉल जैसा वाटरफॉल होता है, वन बाय वन देयर इज अ डिपेंडेंसी, एंड ड्यू टू सम रीजन यहाँ पे कुछ बीच में बग आ गया, ओके, देयर इज नो प्रोविजन की फीडबैक मिले किसी को और सॉल्व हो क्विकली, जो नेक्स्ट अप्रोच में होने वाला है। तो इसमें क्या होगा, ये पूरी कुछ प्रॉब्लम हुआ बीच में, ये पूरी प्रोसेस वापस से रिपीट होती है, मे बी 6 मंथ नहीं लगेंगे, 4 मंथ लगते हैं, लेकिन ये प्रोसेस इज वेरी टीडियस एंड लॉन्ग, ओके। सो वाटरफॉल मॉडल में पहले ऐसा कोड बनाते थे, okay? फिर क्या होगा, एक मेथोडोलॉजी आई मार्केट में, दैट इज कॉल्ड एज अजाइल। इसमें क्या होता है कि सेम थिंग होता ही है, लेकिन देयर आर डिफरेंट पीपल इन्वॉल्व, एंड सब कुछ इटरेशन में होता है इन स्मॉल स्मॉल प्रिंट्स, सो दे डोंट हैव टू वेट फॉर लॉन्ग 6 months, okay। So this agile methodology was always there, means before DevOps as well, okay? Or you can say they grew together properly. So agile development में क्या होता है, small small iterations में होता है, ताकि जल्दी हमको फीडबैक मिल जाए, जल्दी प्रॉब्लम आ गया किसी कोड में तो जल्दी से उसका सॉल्यूशन मिल जाता है, okay? That's what agile improve the software releases quickly. So now instead of 6 months, it will take 2 or 3 months only because of agile methodology. So the same thing I'll explain again now with respect to some CI/CD. Okay. So what is CI and what is CD? So we know that developers write the code. Okay, they send it in a version control, some branch में डालते हैं GitHub के. Okay. सम उसको इंटीग्रेशन करते हैं, कंपाइल करते हैं और उसको पैकेज किया जाता है, देन ऑपरेशंस टीम को देंगे, दे विल टेस्ट इट एंड दे विल मेक इट अवेलेबल टू द पब्लिक ऑन वेब सर्वर। सो डेवलपमेंट टीम ने क्या किया, कोड बिल्ड किया, कंपाइल करके उसको पैकेज करके ऑपरेशंस टीम को दे दिया, और नाउ इट इज डिप्लॉयड। सो ट्रेडिशनल लाइफ साइकिल में क्या हुआ, जब यहाँ टेस्ट हुआ तब डेवलपर्स को पता चला बग, और ये प्रोसेस में ऑलरेडी 6 मंथ चले गए, वापस से ये प्रोसेस वापस से रिपीट होती है ट्रेडिशनल एसडीएलसी में, दैट इज वाटरफॉल मॉडल। बट दिस विल एक्सप्लेन, देन आई विल गो बैक टू दैट सीआई स्लाइड। सो मॉडर्न सीआई/सीडी में क्या होगा पता है क्या, कि जैसे डेवलपर ने पैकेज करके टेस्टिंग कर ली, ओके, यहीं पे टेस्टिंग हो जाएगी और कंटिन्यूस इंटीग्रेशन, कंटिन्यूस टेस्टिंग और कंटिन्यूस डिप्लॉय होके तुरंत डेवलपर को फीडबैक मिल जाएगा. दे वोंट वेट फॉर द ऑपरेशंस टीम्स टू टेस्ट एंड ऑल. ओके, सो इसमें क्या होता है, लाइफ साइकिल इज in done in iterations and it is quick. Okay? Then when the everything is CI is completely tested properly, okay, then the package is given to the operations guy and it is again tested and continuously delivered. So that continuous word comes here, the iterations, okay, continuously building everything. So here this is how the continuous integration and continuous delivery done. That's why we call it CI and CD. So what is continuous integration? Okay, so this slide is very useful. This is done by developer 1, this is done by developer 2, and this is done by developer 3. Okay, so what they will do is they will integrate the code and they will test it. So this integration of everyone's code and testing till this part, there are some other कुछ stages और भी है. This is called as CI. Okay, so most people do not know what is CI. People लगता है कि कुछ तो automation हो रहा है, that is CI. CI means integrating everyone's code and testing it and releasing it. Now the code which is released, generally we say that version 1.0.0, this is released, now deployed in a production. So deployment part will be CD. Okay, so that's what here CI is and here the CD is. And modern CI CD में क्या होता है? Due to agile methodology, they adapt other agile methodology जिसमें iterations होते हैं. Microservices के वजह से क्या होगा? Each team will be working differently. Everyone will be doing compiling, packaging and all. Okay, feedback continuous मिल जाएगा और everything becomes very fast. So CI/CD, modern CI/CD में क्या होता है? Everything is very fast. That's why everyone is going towards the modern CI/CD approach. Okay. So CI/CD में यही होता है, various tools are involved. Okay, that's why it's called as cycle. Whenever you see this cycle, that means सब कुछ continuously हो रहा है. Continuous integration, continuous delivery, continuous testing. Okay, everything is continuous. Feedback is important. 6 month नहीं लगना चाहिए feedback के लिए. Okay, various tools involved है. Okay, so I have already segregated those tools. Okay. I'll explain it in the next slide. Now, if you remember, I started with infrastructure and application. So developers will create application. Okay, DevOps engineers need to make sure that application is deployed. So application कहाँ deploy हो सकता है? अगर on-prem है, so it will be on a VM on VMware. Okay, if it is Azure, it will be Azure VM, Azure virtual machine. If it is on AWS, okay, it will be an AWS EC2 instance. If it is on Google Compute Engine पे. This is I'm just explaining with respect to VM. इसमें containerization भी ऐड कर सकते हैं और इसमें Kubernetes भी ऐड हो सकता है. It means on anything we can deploy. Now हम लोग ट्रेडिशनल वे में क्या करते थे, ये सारे VMs एंड ऑल मैन्युअली बनाते हैं. But in production workload nowadays everywhere, even in interview, if you say that they will strictly ask you कि तुम लोगों ने VM बनाया है, हाँ कैसे बनाया है, you will say I logged in, I went to that option in UI and all. You are completely rejected. क्यों? क्योंकि they expect an answer and this is what expected in production workload, that you do the deployment, sorry, provisioning. So words are also important. Provisioning means creating something for the first time, that is VM is created for the first time. Provisioning of the VM we are doing via code. Okay, and which is very popular code for doing ISC, infrastructure as the code, it is Terraform. You must have heard about Terraform. So क्या हो सकता है, हम लोग टेराफॉर्म डायरेक्टली रन करके वीएम भी बना सकते हैं. ठीक है, लेकिन इसमें क्या होगा कि वो सेंट्रलाइज रिपोजिटरी में नहीं रहेगा, तो उसको हम लोगों को जनरली सेंट्रलाइज रिपोजिटरी में रखना पड़ता है गिट में कोड को. एंड देन ऑन अ सिंगल पुश, वो कोड डिप्लॉय होना चाहिए ऑटोमेटिकली ऑन एनी ऑफ द क्लाउड प्रोवाइडर्स और ऑन प्रेम. उसके लिए जेनकिंस यूजफुल होता है. तो जेनकिंस क्या करेगा, जो भी कोड हमने लिखा है फॉर डिप्लॉइंग एन एप्लीकेशन, सॉरी इंफ्रास्ट्रक्चर ऑन क्लाउड, उसको ऑटोमेट करने का काम करता है जेनकिंस. So here ऑटोमेशन, इसको CI/CD मत बोलो, तो इसमें CI एंड CD इन्वॉल्व नहीं है, इसमें सिर्फ ऑटोमेशन इन्वॉल्व है. दैट्स व्हाई इन ISC ऑटोमेशन यू कैन से. Okay? So generally what we do in DevOps is first we create infra. Infra is also created using code और उसको automate करते हैं. Why automation is needed, that also I'll give a live demo on ISC. Okay? And फिर जो infra ready हुआ, okay? So generally suppose you have created an infrastructure in AWS. Here I am explaining with respect to EC2 VM के हिसाब से. लेकिन अगर वो infra Kubernetes cluster है, in terms of AWS it can be EKS. Okay? Here Docker registry is involved. Okay, so I'll explain this. Just see, understand that we have created this infra, Docker registry, Kubernetes, these two are created, and now we have to deploy something on it. So application इस पे deploy होगा. जो infra हमने previously बनाया IISc पे, उसको CI/CD के through हम लोग deploy करेंगे. So you remember what is Docker? Docker एक containerization platform बनाने में help करता है. ठीक है, तो जनरली हम लोग जो डॉकर की इमेज बनाते हैं, ओके, वो एक डॉकर फाइल से बनाते हैं. ठीक है, तो वो डॉकर फाइल से जब इमेज बनती है उसको ऑटोमेटिकली बिल्ड करके पुश करने का काम. सो हमने इमेज तो बना ली, ठीक है, हमने प्रॉब्लम तो सॉल्व कर लिया, इट वर्क्स ऑन माय सिस्टम. नाउ टेक दिस इमेज एंड डिप्लॉय इट ऑन योर सिस्टम. उसके लिए क्या करना पड़ेगा, उसको कहीं सेंट्रली स्टोर करना पड़ेगा. तो उसको स्टोर करते हैं हम लोग डॉकर रजिस्ट्री में. सो बिल्ड करने का काम, पुश करने का काम हम मैन्युअली भी कर सकते हैं, लेकिन जेनकिंस हमको हेल्प करेगा. जेनकिंस इज वन ऑफ द ऑटोमेशन टूल्स, विल हेल्प इन building the application, that is CI part, build and push to container registry. Okay, then Jenkins also helps in CD part, that is deploying it on the Kubernetes cluster. Image बनने के बाद that image को highly available और scalable रखने के लिए container को हम लोग Kubernetes पे deploy करते हैं, और वहां पे Jenkins plays a very important role in achieving that automation. Okay, and this everything happens with a single commit. Okay, जैसे हम लोग कुछ commit करेंगे या GitHub में डालेंगे, एवरीथिंग रन्स ऑटोमेटिकली. तो इसका डेमो तो अभी पॉसिबल नहीं होगा 1 hour में, लेकिन ISC का मैं डेमो अभी दूंगा. सो दिस इज विथ रिस्पेक्ट टू एनी मींस वेंडर न्यूट्रल है. ये जो डायग्राम है वेंडर न्यूट्रल है. कुबरनेटिस EKS हो सकता है, अज्योर का AKS हो सकता है, गूगल का GK हो सकता है, डॉकर कंटेनर रजिस्ट्री, डॉकर हब हो सकता है, कोई भी. लेकिन AWS CI/CD, and AWS is a popular cloud platform. So AWS ने क्या किया है, उसका खुद का CI/CD चेंज बना के रखा है. Okay, so this AWS code commit was earlier, और ये deprecated हो गया, अभी GitHub यहाँ यूज करते हैं. तो यहाँ पे हम लोग कोड स्टोर करेंगे. कोड बिल्ड हेल्प करता है हमको. इट्स एन इक्विवेलेंट टू जेनकिंस. ओके, सो CI पार्ट ये करेगा. देन हम लोग डॉकर कंटेनर रजिस्ट्री जो मैंने बोला था, जहाँ पे हम लोग इमेजेस स्टोर करते हैं, दैट विल बी इन द ECR, इलास्टिक कंटेनर रजिस्ट्री. एंड दैट इमेज विच इज stored in at a centralized location ECR में, उसको हम लोग EKS पे डिप्लॉय करेंगे. दिस इज ओनली विद AWS CI/CD. Here we can mix and match everything. Here also we can use AWS का एक component, Google का दूसरा component, और only open source tools. So इतने सारे tools याद कैसे रखने का? So I have already prepared a chart. Okay, so every DevOps revolves around these tools only. Most of the important tools I have listed here. Okay, so open source, enterprise. Okay, AWS का equivalent क्या है, Azure का क्या है, GCP का क्या है. Okay, so let's start from the bottom. अगर हमको ISC करना है, infrastructure as a code, कोड से कुछ रिसोर्सेज बनाने हैं. Okay, suppose in AWS हमको EC2 इंस्टेंस बनाना है, VM, then we'll use Terraform. Okay, और Terraform ओपन सोर्स भी है और उसका एंटरप्राइज वर्जन भी अवेलेबल है. इफ यू आर ऑन AWS, तो AWS ने अपना खुद का ISC कोड बनाया हुआ है, दैट इज कॉल्ड एज क्लाउड फॉर्मेशन. ओके, दैट क्लाउड फॉर्मेशन विल नॉट वर्क ऑन Azure एंड GCP, क्योंकि Azure एंड GCP ने ARM एंड बाइसेप, और GCP ने डिप्लॉयमेंट मैनेजर ऑलरेडी बना के रखा है. So these three cannot be used interchangeably, but Terraform can be used on everywhere, AWS, Azure, and GCP. So most of the times people learn Terraform if the project requirement is that you need to learn CloudFormation. Okay, if they have chosen this CloudFormation as the tool for ISC, then you'll have to learn CloudFormation. but I recommend learning Terraform for ISC. Okay, then Kubernetes. Okay, अगर हमको ओपन सोर्स टूल यूज करने हैं तो वैनिला कुबरनेटिस है, K3s है, माइक्रोकेटस है. अगर हमको ऑन प्रेम और एंटरप्राइज लेवल के चाहिए तो ओपन शिफ्ट, रैंचर, VMware Tanzu. वी आर ऑन AWS, EKS, AKS, GKE. सो अभी हमको नहीं पता कि एज अ फ्रेशर और इवन एज अ एक्सपीरियंस डेवऑप्स इंजीनियर कौन से टेक्नोलॉजी पे काम करने को मिलेगा. तो व्हाट आई डू इन माय फुल कोर्स इज I teach with respect to open source and one cloud. If you learn about one tool, it's very easy to learn any other tool. With some difference, सिर्फ syntax का खेल है. So ये बहुत important है CI/CD. Okay. So that was all about the presentation. Okay. So if you have any questions, hope I have done some justice to combine all tools together and you're able to understand. Okay. So in short, I'll say DevOps की वजह से everything is quick and fast because it doesn't use a waterfall model. It uses continuous integration, testing, and deployment. And uh, and another one is microservices. And microservices is used by containers. Okay, containers की वजह से हम लोग microservices quickly बना पाते हैं. And वो बनाने के लिए हमको हेल्प करता है Docker. And उसको स्केल करने के लिए हेल्प करता है Kubernetes. And कंटेनराइजेशन एक मेन प्रॉब्लम सॉल्व करता है दैट इट वर्क्स ऑन माय सिस्टम एंड नॉट योर्स. कभी ट्राई करो स्क्रैच से पूरा एप्लीकेशन बनाने में और ट्राई करो विद डॉकर. इट विल सेव अ लॉट ऑफ टाइम. ओके, सो इफ यू हैव एनी क्वेश्चंस आस्क मी. I'll be giving a small demo. It will take only 5 minutes in which we will deploy an EC2 instance automatically with a single push. Any question? You can ask any silly question. If any concept is not clear and anything about tool, whatever you want, you can ask me. So if you see here, these are the tools, very important tools. Linux आना चाहिए, Terraform आना चाहिए, ठीक है, Git आना चाहिए, Ansible आना चाहिए. Ansible का मैंने example नहीं दिया. Then these are all monitoring tools: Prometheus, Grafana, Loki, PLK Stack. Docker आना चाहिए हमको DevOps में, Kubernetes, Jenkins, and Argo CD. It's some GitOps principle. Cannot cover everything in this small 1 hour session. Okay. But this is all this icons, okay, and this table is quite important. So everything revolves around this. And DevOps is a methodology. Okay, तुम लोग कौन सा approach use करते हो, okay, कौन सा tool use करते हो. It's a philosophy. It's not just about using the tools. Anyone has any question, you can ask. Or location, Saurabh, can I go ahead with the demo?
गाइस कोई भी क्वेश्चन हो पूछ लो, क्योंकि डेमो के अंदर अगर आप कोर्स ज्वाइन करो ना करो, बट डेमो के अंदर आप क्लियर कर सकते हो अपने डाउट लाइव. तो इट्स गुड कि आप क्वेश्चन.
So, okay, so you have answered all questions in the chat, or I need to answer anything? Okay, let me know if anything needs to be answered. Okay.
Harsh has question something. Sir, please create EC2 instance specific type with Terraform like install dependency of Java SDK 21.
वो डेमो तो नहीं हो पाएगा अभी, वो रेडी नहीं है. लेकिन it's possible whatever you have said. I'll just give a small demo of creating an EC2 instance. Okay. So इसमें ये जो है बहुत अच्छा क्वेश्चन है. I'll quickly answer this in this way. Excuse me. So बहुत अच्छा क्वेश्चन है. EC2 इंस्टेंस हम लोग क्या करेंगे, टेराफॉर्म से बनाएंगे. दैट इज अ ISC tool. Okay. Now whatever dependencies you are saying, okay, installing Java, after creating an EC2 instance we need to install Java, okay, a specific version of Java like JDK 21 he is saying, okay, SDK. So इसके लिए टू मेथड्स है. पहले ISC करो, okay, EC2 instance बनाओ, and while creating EC2 instance, AWS में एक option है called user data. Okay, so in Terraform also you can do that using user data. उसमें एक script लिखेंगे हम लोग जिसमें if you are on a Red Hat system yum-y install OpenJDK या जो भी हमको चाहिए वो script के through करेंगे. Okay, one method is script, but what I recommend is let's not do using script. Let's always do using Ansible. So this also is very important. Ansible की infrastructure तो तुम बना लो IAC से, that is Terraform, but whenever you want to do some configuration management, this OpenJDK is a configuration management. So configuration management के लिए don't use script, always use some configuration management tools like Ansible, Chef, Puppet. Ansible is quite popular and easy to learn. So हम लोग यही thing Ansible से करेंगे. The only thing is Ansible is idempotent. Idempotent का मतलब it will not try to uh, retry installing something if it already exists. Okay. So this I also teach in my course how to do this using Terraform and then
Okay.
Ansible. Okay. Any other
Okay.
question?
मेरा एक
Next.
क्वेश्चन है, मैंने चैट पे लिखा है.
Uh-huh.
What's the difference between CloudFormation serverless or framework and Terraform?
Yeah, so the short answer is CloudFormation is specific to AWS only. Okay, and Terraform we can use on AWS, Azure, Google, VMware, anywhere. Means syntax एक बार Terraform का सीख लो, then that can be used anywhere. जिसके providers Terraform ने दिए हैं, लेकिन CloudFormation सिर्फ AWS पे चलेगा.
और सर्वरलेस
एक्चुअली CloudFormation सर्वरलेस का मतलब ये है कि हमको सर्वर्स नहीं दिखते वो, राइट. जब भी सर्वरलेस का मतलब है कि वो मैनेज्ड बाय AWS, we do not
सो
manage it.
इस पे मेरा एक क्वेश्चन है. क्लाउड फॉर्मेशन का जो टेम्पलेट है और सर्वरलेस का जो टेम्पलेट है, दोनों का YAML सिंटैक्स ही होता है, राइट? और
राइट
दोनों
राइट
दोनों एक ही
राइट,
चीज है या क्या है, कैसा है?
दोनों अलग अलग है. मैं वही बोल रहा हूँ कि
हाँ
दो डिफरेंट कंसेप्ट को एक साथ पूछा है तुमने. तो
हाँ.
क्लाउड फॉर्मेशन का यूज करके सर्वरलेस फ्रेमवर्क बनाना. मे बी दैट्स व्हाट यू वांट टू से.
Okay, moving towards our main demo, जो आपका डेमो है वो एक बार आप दिखा दीजिए जो आपने प्रिपेयर किया,
Okay.
so that people get overview.
So I already have a Git repository. Okay. So इसमें क्या होगा, I have already written a Terraform code जिसका यूज करके हम लोग T2 micro instance बनाते हैं. So code and all I won't be able to explain, but एक इसमें क्या कर रहा हूँ मैं, एक DevOps demo instance बना रहा हूँ. Okay, using T2 micro instance type. Okay, so very simple thing और उसका output आ जाएगा screen पे. And here some buckets and all are created to store Terraform tf state file and all, so that's quite technical. Okay. So in short ये एक स्क्रिप्ट रन होगी और यू कैन से टेराफॉर्म कोड रन होगा वाया CI/CD पाइपलाइन. तो इस केस में हम लोग जेनकिंस यूज नहीं कर रहे हैं. गिटहब का खुद का एक गिटहब एक्शंस करके टूल है, उसमें क्या करना पड़ता है, एक फाइल बनानी पड़ती है YML, उसमें मैं लिखूंगा. तो जनरली टेराफॉर्म जब हम लोग रन करते हैं तो उसमें इनिशियलाइजेशन होता है, प्लानिंग होता है एंड अप्लाई होता है. सो मैंने अप्लाई करने के बाद यहाँ डिस्ट्रॉय भी कर दिया है. So what I'll do is I'll make a change in this code, and when the code is changed, okay, it will automatically deploy something in the AWS. So I'll open my AWS console first. My screen is visible, right?
Yeah, it's visible.
Okay. So I just want to show कि यहाँ पे कितने VMs already है and जब when I'll run the automation pipeline, so कितने आ जाएंगे. So instances में we are in UST East 1 region. All states I'm listing. एक DevOps VM है जो running है, ठीक है. इसके अलावा और कुछ नहीं है. अभी हम लोग एक नया VM बनाएंगे via code, okay? And that too on a single push or in GitHub repository. So let's see that. So code is here. This code, this much code is for the automation. Here what it does is it runs 3 command: init, plan and apply. Okay, here I have written destroy. I'll make it apply now. And one more change we can do is, though it is not required, हम लोग instance का नाम change कर सकते हैं. यहाँ पे 1 का 2 कर सकते हैं यहाँ पे. लेकिन in short we have to make any change, so I already have an ID open here. This is the main code. Stop. Here. So here, this code we don't need to change now. I'll just change the logic here. This is the pipeline which is written, very simple one. So I'll just edit it. I'll just say apply here. Again we'll do the destroy. So Terraform apply से क्या होता है कि whatever we have written in the code that gets deployed. And also do it from command line. Let's do ls pim dot github workflows terraform.yml. ये एक्चुअली ऑटोमेशन है, इस फाइल में हम लोग डिफाइन करते हैं. इसको अप्लाई को मैं डिस्ट्रॉय करता हूँ, कमांड लाइन से प्रॉपर हो जाएगा. ओके, इट्स अप्लाई ओनली. इसको सेव कर दिया मैंने. नाउ आई विल डू पुश git add and git commit. Just say apply code and git push. When I'll push the code, okay, just need to check that it's pushed properly. Okay, so this is done. Let's go back to our repository जहाँ पे हम लोगों ने GitHub actions का यूज करके pipeline बनाई है. So if you see something is running, so let's go to this actions and just click on this apply code. So क्या हो रहा है, एक automation start हो गया. So if we click on this, okay, so it is showing what it has done. It has done some setup job. Okay, so plan में दिखाता है कि वो क्या करने वाला है. Okay, then it's actually doing apply as well. So apply started, and if you see apply completed, एक resource add हो गया है, 0 change 0 destroy, और एक बन गया है हमारा EC2 instance which has this public IP address. Okay, so if you go to my EC2 dashboard, okay, just refresh this page. Okay, the single click, what we did is we just created an instance. Okay, so you see DevOps demo instance 1 and इसका IP address यही है जो मैंने अभी कॉपी किया है, ending with 13. So हमको IP address भी वहीं पे मिल गया in that output. So if you go back there, it was a very small demo but very effective. Okay, so here all the concepts of IAC and automation both are there. So if you see, this is successful apply code, Terraform. So this all the steps executed properly. If there is an error, we can check here. यहाँ पे स्क्रीन पे दिख जाएगा, इसने आउटपुट भी कर दिया ऑटोमेटिकली पब्लिक आईपी एड्रेस of that EC2 instance. So whatever logic we have to write, we can write it and we can deploy it. So IAC बन गया है, infrastructure बन गया, अभी ये infra पे हम लोग application deploy कर सकते हैं. Okay. That was a small demo. What I will do is I'll quickly just destroy it. Okay, so that makes sense. From the same file, I'll just destroy it. Our demo is over. So what I'll do is stop apply. प्रोडक्शन एनवायरनमेंट में हम लोग ऐसा नहीं करेंगे. आफ्टर प्लानिंग, ओके, अप्लाई करने के लिए अप्रूवल लगता है एंड दैट अप्लाई इज नॉट ऑटो अप्रूव. सो इफ यू सी हियर टेराफॉर्म अप्लाई ऑटो अप्रूव रहता है, उसको मैन्युअली करना पड़ता है जब तक उसको वैलिडेट नहीं करते. बट फॉर डेमो इट इज ऑटो अप्रूव. प्लानिंग कैन बी डन बिकॉज इट डजंट चेंज एनीथिंग, लेकिन इस केस में so, थोड़ी देर में ये डिस्ट्रॉय हो जाएगा. Okay, so pipeline must have started running. Whenever I push, something will start here in actions. So the same thing can be done by Jenkins as well. Okay, so ये GitHub में easy जाता है क्योंकि हमारा source code भी वही रहता है. Jenkins में थोड़ा सा setup बनाने में time लगेगा. So it is started. Destroy this. It's completed. We'll go to our screen and we can see that EC2 instances and destroy. So destroy में थोड़ा time लगेगा. So let's see what it is doing. Terraform तो apply लिखा है लेकिन हमने command destroy किया है. So it is still destroying something. You can also see the output in the screen. And if we go to here, it must have started terminating it. Instead of running, it is shutting down, and sometime it will show terminated. So that was all about the demo. How to achieve infrastructure as a code automation.
Nice. Nice. So आप सभी ने देखा, I can see like many of them have already left.
Yeah.
And only 3-4 लोग ही बचे सीरियस जो है. तो क्योंकि आप अभी यहाँ तक आए हुए हो, ठीक है, एंड मैं अभी फिलहाल, हाँ, तो मैं अभी थोड़ा सा क्वेश्चंस वगैरह जो पहले उन्होंने पूछे थे